Okay, in part two in our lesson of probability, we're going to talk about what are called dependent events. Remember, independent events were like rolling dice, where one roll had nothing to do with the next roll. Well, dependent is the exact opposite. The definition we give here is the outcome of an event changes the outcome of the next event. So once something happens, then it changes what's going to happen in the next event. A good example of this is choosing cards from a deck. The reason that is dependent event is once you have chosen, let's say, the ace of clubs from a deck, if you don't replace it, then there are now only 51 cards in the deck instead of 52, and so everything is changed from a probability perspective. And so that's what makes it a dependent event. Another is that we use a lot is balls in a bag. There are 12 balls in a bag. Once you choose one, now there's only 11 left in the bag, and so the probability is changed. We'll do a lot of problems with decks of cards. If you don't know things about decks of cards, here just as a quick review, there are 4 suits. The 2 black suits are clubs and spades. The 2 reds are hearts and diamonds. Another important thing to remember is there are 13 cards per suit. Each suit, each club, spade, heart, or diamond, there's an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack, a queen, and a king. And the jack, queen, and king are what we call face cards because they've got pictures of jacks, a jack or a queen or a king on there. And so if I ever ask for a question about face cards, we're referring to the jack, queen, or king. The important thing is there are 13 cards in a suit. There are 4 of each card, so there are 4 aces, 4 twos, 4 threes, and then there are 52 total cards in a deck of cards. So example 1 says you're drawing 2 cards from a standard deck of cards. So now this is different because this is now a combination because we're not putting any order on how these cards are found. And so the total number of cards or possibilities of drawing 2 cards is actually 52, and then you're choosing 2 cards from that 52 deck. And so the total possibility is just 52 choose 2, which you can calculate, which would just be 52 times 51 divided by 2, which is 1,326. So there are actually 1,326 ways of drawing 2 cards from a deck of cards. So it says, what's the probability of drawing 2 clubs? Well, the total possible outcomes is 1,326. So the positive outcomes is drawing 2 clubs. Well, how many clubs are there? There are 13 per suit, so there are 13 clubs, and I want to draw 2 of them. It doesn't matter the order I draw those 2 clubs. And so again, it's a combination. This isn't a permutation problem because order doesn't matter when I draw the cards. I'm just trying to draw the cards out. So 13 choose 2 is just going to be 13 times 12 over 2 times 1. And so it's going to be 13 times 6, which is 78 over 26. And so you need to simplify this. I can notice that I know 13 goes into 78, and I know 13 goes into this because you got a 13 and a 26. And then they're both even, so at least 26 goes into both of them. So 26 goes into 78 3 times, and then 26 goes into 1326 51 times. So it's at least 3 out of 51. Well, 3 does go into 51 17 times, and so the answer to this question is 1 out of 17. But essentially what it was 13 choose 2 divided by 52 choose 2. That was your probability. The probability of drawing 2 aces, well, it's still 1326 on the bottom, but on the top, you're now only choosing from 4 possibilities. You got 4 aces total. I want to choose 2 of them, so it's going to be 4 choose 2, which is 4 times 3 over 2 times 1, which is just going to equal 6. So there are 6 possibilities. So when we simplify this, 6 does go into 1326 because 1326 is divisible by 2 and 3. And so when you divide this out, well, obviously 6 goes into 6 one time, and then 6 goes into 1326 221 times. So the probability, if you're just drawing 2 random cards, of drawing 2 aces is 1 out of 221. Now what you might notice is that's going to be the same probability of drawing 2 twos or 2 threes. So the math would be the exact same because there are 4 twos, 4 threes, 4 fours. All those would be the same. So the probability of getting what's called a pair when you're playing cards is always going to be, if you just draw 2 cards out, it's always going to be 1 out of 221. Some more examples of this. What is the probability of drawing two face cards? Well, again, we're drawing two cards, so 13, 26. If you want two face cards, you got to ask yourself, how many face cards are there? Well, there are 4 jacks, 4 queens, and 4 kings, so there are 12 face cards. And I want to choose 2 of them, so it's going to be 12 times 11, 2 times 1, and so that's just going to be 66 over 13, 26. Like I said, I know 6 goes into both of these, and so it's going to be 11 over 221. You should check to see if 11 goes into 221, which it doesn't. So the probability of drawing 2 face cards is 11 out of 221. The probability of drawing a red card and a blue card. Okay, so essentially what this would be is, what's the probability of, if you start with any red card, so there are 26 red cards, and you just want to choose one of them. And so 26 choose 1 is just 26. And all 26 of those red cards can then be paired up with a blue, this should be a black card. There are no blue cards, and so it should be a black card. Would be also 26 choose 1. And so the probability of choosing a black card and a red card would be 26 times 26, right? Because there are 26 red cards. You want to pair that up with 26 black cards. And so that's just going to give you 676. And so you're going to have 676 over 1326. When you do this, you can simplify. We know that 26 goes into both of these. 26 goes into 13, 26, 51 times. So you end up with 26 over 51. That simplifies some more. Actually, it doesn't simplify anymore. So 26 over 51 would be your answer. That's the probability of drawing a red card and then a black card. And red card and a black card is 26 over 51. Okay, the next example we're looking at is, you've got a bag. It contains 5 red balls, 3 green balls, 4 blue balls. So there are 12 total balls. And it says each ball is equally likely to be chosen. Balls are drawn without replacement. So we're not replacing these balls back into the bag. So it says, what's the probability of drawing 2 green balls? Well, that means we've drawn 2 balls. And so the total possibilities would be 12 balls, choose 2, which is going to be, you can figure this out, but it turns out to be 66. So that's our total possibility. And the probability of drawing 2 green, well, I've got 3 green balls and I want 2 of them, so it's just going to be 3 choose 2. And 3 choose 2 is just 3 times 2 over 2 times 1, which equals 3. So the probability of drawing out of this bag, if you want to, if you win a prize for drawing 2 green balls, you would do that 3 out of every 66 times, or simplified, 1 out of every 22 times you drew 2 balls, they would both be green. That's the probability of that happening. It says, what's the probability of drawing a red ball and a green ball? Well, that would be 5 choose 2, or 5 choose 1, right? Because you're drawing 1 red, and then you're going to multiply that times 5. Not 5, there are 3 green. So 3 green, choose 1. 5 choose 1 and 3 choose 1 are just 5 and 3. So that means there are 15 ways of drawing a red ball and a green ball. And there are 66 total, so the probability is 15 over 66, which simplifies to 5 over 22. So 5 out of 22 times you would draw a red ball and a green ball. And then the next one says, what is the probability that the first 5 balls drawn are red? So this time you're drawing 5 balls, and so you're actually doing 12 choose 5. And when you do 12 choose 5, it's going to be 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2. And so that's going to be 5 times 2 is 10, 4 times 3 is 12, so it's just going to be 9 times 8 times 11, which is 792. So there's 792 ways of this happening. You want to draw 5 red balls. So you got 5 balls. You want to choose 5 of them, 5 red, and you want to choose all 5 of them. There's only one way to choose all 5 red balls. And so the probability of this happening is 1 out of 792 times. So if you were drawing these balls out, there's only 1 out of 792 times that you actually draw all 5 red balls from the start. The last one we'll look at is what is the probability of drawing a green ball and then a red ball. Now this one's a little bit more difficult, and this will lead into some of the compound probability problems we'll do next time. And to do this one, we would actually want to do a tree diagram. On a tree diagram, we would look, you look at it this way, and this would be drawing a green ball first, drawing a red ball first, drawing if we go back and look at it, a blue ball first. The probability of drawing a green ball first is 5 out of 12 because there are 5 green balls and, actually that's red balls, isn't it? And so it would just be 3 out of 12, which is the same as 1/4. So the probability of drawing a green ball fourth is red 1/4. Probability of drawing a red ball first is 5 out of 12, and a blue ball first would be 4 out of 12, which is the same as 1/3. But all we're worried about is drawing green ball first. And the probability of drawing a red after the green would be, there are now only 11 balls in there, and 5 of them are red. And so whenever you have events like this where you can do a tree diagram to map out what's going on, the probability of doing a green then a red is just 1/4 times 5/11, which would be 5 out of 44. And so there are 5 out of 44 ways of drawing a green ball and then immediately a red ball after that. And that would be your answer to that problem. And we'll do some more problems next week that are more like this one.